Welcome back. I hope you are doing great. As a part of this lecture, we'll understand the transformations on RDDs. Any idea how do we manipulate the RDDs? I hope you guys understand what is manipulation, right? We say manipulation for the transformation. We say manipulation if you are meddling with that data. In this case, the core data structure is RDD. So how do we manipulate the RDDs? We manipulate the RDDs in the same way as we manipulate the data frames. Only the difference is in case of data frames, we are manipulating the Spark types. But in case of RDDs, we are manipulating the raw Java or Scala objects. So whenever you want to manipulate the RDDs, obviously you got to manipulate the Java or Scala objects. But in case of data frames, we'll be manipulating the Spark types. Because you have to manipulate the core Java or Scala object, there is also a dearth of helper methods or functions to manipulate the RDDs. Because there is a dearth of helper methods, obviously developer has to define whether it is a filter, whether it is a map function, whether if he or she wants to do an aggregation, and if he or she wants to do any other manipulation, they have to define these things. It is not that we don't have the functions methods at all, but as compared to the data frames, the functions are less to manipulate the RDDs. If the functions are less, obviously developers has to define them, right, as a part of their data engineering problem or a data analysis problem. So how do you go about transforming the RDDs? Any thoughts here? Can you think of? We can transform an RDD almost like transforming the structured APIs only, like data frames. What are the transformations you would have seen in structured APIs? More or less same kind of a transformations are available in the RDDs also. The transformation is transformation, whether you are doing on an RDD or data frames. So many of the transformations mirror the same functionality that whatever we have seen as a part of the data frames. So whenever you do a transformation in RDD, we specify a transformation on one RDD to create another. For example, we have created a RDD1 with some collection. Okay, so we want to filter on this RDD1. Then we'll be creating a RDD2. So we specify a transformation on one RDD to create another. So when we do a transformations on an RDD, in a way we are defining an RDD as a dependency to another along with some manipulation of the data contained in that RDD. You can recollect a RDD lineage here. Having understood how do we go about performing a transformation on RDDs, let us look through what are the different types of transformations which are available for RDDs. Okay. First and foremost thing is we have distinct, the second one being the filter, the third one being the map, the fourth one being the flat map. Yes, these are couple of transformations which are available only in the RDDs. We do have sort, which was available in data frame as well, and we do have splits, which was available in data frame as well. Let us see all these transformations one by one. Distinct, it is pretty straightforward. We have used the distinct in data frames also, the variations of the distinct in data frames. In the same way, instead of finding the distinct values in a data frame, we are going to find the distinct values in the RDDs here. As you know, distinct values is nothing but unique values. Okay, so here when we apply a distinct on this RDD, it will find all the distinct words in this RDD. Isn't it simple? It is simple. The next one is the filter. It is again a intuitive function. Almost filtering is equivalent to creating a where class. Even we have seen that as a part of the data frames as well. When you specify a filter, you can look through the records in the RDD and see which one matches that predicate function. So to filter, what you got to do is you need to define a function. Okay. Then this function will return a boolean type to be used as a filter function. So you define a function and filter the records or elements of an RDD by using that function. For example, here we have a function. The function name is starts with. Okay, this function is going to identify all the words which are starting with yes. So we have defined a function. That is the first thing. The next, this is an RDD here. Now we are using a filter, which is one of the transformation on RDD. What is this guy doing here? The lambda functions, we can also say them as a anonymous functions or the functions without any names. In this case, you can see what it is doing is it is taking the elements of an RDD one by one and it is seeing if this word is starting with yes or not in this case. So we define a function first, then using that function we are filtering. Whichever is evaluating to true, that will be collected. Whichever is evaluating to false, that will be rejected. That is how we use the filter. Whatever the filter which we have seen, that is a simple transformation. But sometimes we may need something more. Like we want to map one value with the another value, like extracting a value based on the same key, comparing a set of values. In that case, we can use the map. To use the map, you can specify a function that returns the value that you want given the correct input. Then on top of that, you apply that function record by record. For example, here, if you see, again, we are using the lambda function. Unlike the filter, you can see we are saying a word here and word 0, that is the first element of that word, and words start with. So we are going record by record and applying this function. Once you are done with that, you can also subsequently filter on this by selecting the relevant boolean value in the new function. For example, like this. Okay, anyway, when we see the example in a hands-on session, it will be bit more clearer for you. Next, the flat map. Flat map provides an extension of the map function, whatever we looked at one slide before. Sometimes each current row should return the multiple rows. That is when you should be using the flat map. For example, when you take a set of words and you want to flat map that into characters, that is when we can use the flat map. One important thing here is the flat map requires that the output of the map function be an iterable, means it has to iterate through the different elements in a word. Moving on, we have sort. Just like any other RDD operation, we can use the sort by specifying a sort by method on an RDD. It's almost like a applying any other function whatever we have seen so far. What it will do is it will extract a value from the objects in your RDD and sort based on that. Okay, for example, we have seen a words RDD which will have a collection of the words. In this case, when you say sort, it will sort the values based on the maybe alphabetical order. We have a function here. In this function, what is happening is this is an RDD and we are using a sort by method. Again, we are using a lambda function. Just notice here, we are using one more function here. Okay, what this will do is it will sort by all the words according to their length. So one thing you would have noticed so far, whatever the transformations we want to do in RDD, you are somehow taking a help of the functions, then applying the transformations. But if you remember, in data frames, you are using the transformations directly on the data frames. So that is one of the very, very important difference between the data frames and RDDs. As I have already indicated in my earlier sessions, we are covering the RDD in case if you want to just browse through the legacy code. And we have discussed all the reasons why we should be using the RDD. One of the last transformation available, which we'll be discussing as a part of this lecture, is random split. We can also randomly split an RDD into an array of RDDs. How do you do that? Very, very simple. Use a random split transformation here. So what it does is it accepts the array of weights and also random seed. Okay, so we have already seen whenever you are splitting, whether it is a data frame or an RDD, you have to provide a seed value because algorithm has to start from that particular value to start splitting, right? That is the reason. So what we are doing is we have taken an RDD named words and we are random splitting that based on this weight and the seed value. And in this, we'll get a two arrays having that 50-50% of the words from this RDD. Excellent. We'll see all these examples as a part of our hands-on session. Thank you. You have a wonderful time.